For our case study, was trying to find out the difference between the yo-yo expert and beginners playing styles. And then after recording the two people playing yo-yo, we could see it pretty clear that their difference is pretty huge. And then after looking at the data collected by the device, we could find their playing styles are different in many ways. So we did some plots on the overall data, and this one's for the beginner. We can see the curves are pretty messed up here. And then for this is for the this is for data of the expert. You can see the pattern is pretty clear. And then we also did a comparison on them. We can see the red lines are for the experts, and then the blue ones for the beginners. And then we did a correlation matrix here, and then we can see there are some variables that are that have high correlations. Yeah, so for the analysis part, we just chose like essential parameters like quaternion and gravity and stuff, and then based on that we did the decision tree, and then we generated the ROC curve, and then generated the table to see how the performance was going. So for my part, I chose 3 parameters to do the prediction. I chose motion quaternion x, accelerometer acceleration x, and motion pitch for the decision tree. And then basically we used the same method, and then after doing the computation, we could get the ROC curve, and then the AUC, and then the accuracy, precision, and recall table. So this is the ROC curve. We can see this is pretty similar as the previous one. And then we can get the area under the curve is 0.999 something, pretty high. And then at a threshold equals to 0.7, we can get accuracy is pretty high, and precision and recall and are both pretty high.
Hi everyone, my name is Jiaxi. I'm going to run the prediction model for those variables. In our datasets, I found out that the mean between expert and beginner are largely different for those variables. I also run the PCA model. The absolute values for those 3 variables are largely different between each other for expert and beginner as well. So there must be some correlations for those 3 variables to determine the performance of beginner or expert. Then I run the prediction model by classification tree, and then I've seen a pretty efficiency in my model, and the output is pretty surprising that I have 99% for accuracy and precision, as well as recall as the results, which means that my model is best to capture the differences between the expert and beginner's performance. Also, I'm wondering how could I use those existing data sets to determine a new people whether he or she is an expert or beginner. To run this, I start with acceleration y, the indicator, to separate them into expert and beginner for 2 groups, and then each one has 6 groups of data for 3 indicator, mean standard deviation, and a mean square error. With doing so and combined together in the final step, I have such data sets that saying I have expert and beginner for 6 groups of data, and then for those 9 indicators in total. And by doing so, then if I have new people who is performed on yoyo, and then he has such data set as the output, then I can decide whether he or she is an expert. And by the result of this, this people is actually an expert. But which indicator composite most determinations for the performance output, this is remain on question.
I'm analyzing the gravity X, gravity Y, and rho, the 3 variables from the collecting data, and from the plot, and then I plot each point versus the versus the time. And from the plots above, we can notice that expert's motion is more cycle and periodic. However, normal person would have lots of data stay together in a close position with lots of large outliers. So I decided to use the mean sum of outliers away from one standard deviation and variance as 3 predictors for this data to create classification tree and do a prediction. And I split the data into 2 portions. One is the training table and the other one is the testing table. Okay, and after generating the table, I create this classification tree, and I think maybe is not enough data, so the classification tree, or maybe some more reasons, the classification tree is so simple. And I try to test this classification tree with the training data again, and also with the testing data. The result is quite great though, and we can see that using the training data to test the tree is like 100% accurate with no error. And then I use the new testing data to test the tree. The result is like only 1 error in the prediction, and the accuracy is 87.5%. So I would say if I have more data, the classification tree will be more accurate and will be more useful as well.
To wrap up, even though we have 4 different models in prediction for 3 variables differently chosen for each model, we can conclude that yoyo performance is really determined by variables such as acceleration, the coordinate, the motion pitch, as well as gravity. So the faster the acceleration, the better the performance, as well as the coordinate. On the other hand, Wang has proved that in his test, more datasets are required to perform more accurate results. And also, by his model, we can use his existing datasets to predict others' performance on yoyo to determine whether he or she is an expert or beginner. Thanks for watching us with our model. We really appreciate that.